Okay, so what's the advantage of this one over the previous one?
Faster.
I don't think it's any faster. Well, actually, you're right. It is faster. Why is it faster?
Because you have not as big as an ALU.
Right. So the ALU is quicker, so that's great. It consumes
space.
What did we eliminate space-wise?
We took away registers.
Quotient register.
We got rid of the quotient register and
Cut the divisor in half.
they cut the divisor in half. Right. So we got rid of some registers, so that's great.
It looks a lot like a multiplier now.
How did you know that?
Just intuition.
Literacy?
Yeah.
I know. It's a powerful tool, I've learned.
Literacy is?
Yes.
Sometimes.
It ends up being you use the same hardware for both, as long as you put in your control logic correctly. That way you only need one 32-bit ALU for both the multiplication
Yay.
and the division. So exactly. Yay!
Less space.
All right. So what if we, now that we've made it fairly small, what if we wanted 100% performance? What could we do?
Trim it down.
No, performance, we don't care about how big it is. You can use all the registers you want, all the area. You can take up
Let's do the multiplex.
the multiplex.
Yeah.
Sure.
But can we do that in division?
No.
Someone said no. Why can't we do it in division?
Because it's not adding stuff.
It's not adding, but we could just do subtraction.
But
But-
subtract by what?
You'd have to count the number of times you subtracted.
Right. The problem is
It
we
would
have
change.
every step we have to decide whether we need to restore or not. And so that control step, we can't do it in parallel. So it ends up being that we can't do the same thing with multiplication as we can do with division, which means that division is way slower.
Yeah.
Yeah. Can't use parallel hardware as a multiplier. Subtraction is conditional. Do we subtract or do we not subtract? See, multiplication, you just add it, right? Yeah.
To subtract or
To not to subtract, that's the question. You know, if you add 0, you know, you're good. But if you subtract and get negative, we have to restore, so there's a conditional one. Ends up being that division will get some really tricky hardware. The book goes into something called SRT division, which they memorize the division of like 4-bit by 4-bit numbers, and they try and use a way to index into a table to predict what the final answer should be while they're in parallel doing a couple of calculations.
That sounds too
Is this what
complicated.
you're talking about
Wait.
prediction before and how
What?
it's terrible?
Yeah, prediction. Right. So they're doing prediction. They're trying to literally predict the answer, and hopefully most of the time they get it right, or more often than they get it wrong, so that they can speed it up. Ends up being way too complicated, and we are not going to do that because this is undergraduate architecture.
Yes.
Still requires multiple steps, and you can't pipeline it. And whenever you hear the words "can't pipeline it," there's only
Sadness.
one thing you should see. Yeah, exactly. It's basically this.
Sadness.
Yeah, you should just have the big unhappy
Takes
sign.
forever.
It takes forever. Yeah, terrible, terrible, terrible operation.
Sad.
But-
So don't do it.
Don't ever divide or use modules.
Never divide.
No. Obviously, you want to use it because in hardware you can still do division quicker than if you tried to write a software routine for it.
So just do it this way.
For our homework, yeah, do it this way. But if you were to design a processor, you'd want to do it this way first. When you go in your job and they say, "Hey, we need a new processor," Intel's just not doing it for us.
Yeah, they're totally gonna ask me that.
I'm gonna ask the new guy.
Ask the new guy, "Hey, you got a degree,
Hey, you know
right?
what you're doing."
You know what you're doing."
Design a processor for me.
Yeah, we need a processor.
Nah, that ain't gonna happen.
All
That's
right.
the one that goes in the computer, right?
Nice. Well played, sir.
Job security.
So MIPS, just like with multiplication, you had your high, which is the remainder, and your low is the quotient. Another reason to do it the way I just showed on the board. Hey, look, the high is the remainder. Ha, ha, ha. And the low is the quotient. There we go. Low. Again, you can do the division and do the checks. There's no overflow or divide by 0 checking, so you must do that with software. I don't remember what it does if you try and divide by 0. Probably just says
Sadness.
whatever.
It destroys the computer.
It just
The computer blows up.
You still use the move. Next time, could you play like the Star Wars theme?
We'll work on it.
All right, and you can move from high, move from low. It's the same operation. Okay. Man, we're doing great.
Homework.